Hey, hello everyone. So today's problem is minimize XOR or XOR. So what is exactly XOR is we should know. First thing is when it is a kind of a logic gate or logic in which we usually use in engineering, as you guys also know. So what does this logic gate used for? They are mostly used in electricals, but definitely we need to code the different logic gates too. So what is exactly XOR is when we input two different units, either 0 or 1 bits, and if both are same then it will output 0, otherwise it will output 1. Okay, so what is the question here? Let's start with that. We have been given two integers a and b, that is num1 and num2, and we have to find a positive integer x. What this positive integer x will do is it should have equal number of bits as in num2, and x XOR num1 should be minimal. And we should note that XOR is the bitwise XOR operation, and we have to return the integer x. Test case such that x is uniquely determined and number of the set bits of an integer is the number of ones in its binary representation. So num1 num2 we have been given, we have to just find a number whose XOR with num1 is minimal with equal number of bits as in num2. What is bits? Equal number of set bits means equal number of occurrences of 1. Okay, other than that, yeah, so that's it. So what we can do is, first of all we will count the number of set bits in num2. Then after counting the number of set bits in num2, we will check in num1 where the 1 is occur. So we have been given constraint 10 raised to the power 9, so we can go up to 2 raised to the power 32, no issues. Okay, and even 2 raised to the power 31 will work out, but let's say for safe side 2 raised to the power 32. So we can have if I have a vector with 2 raised to the power with 32 index 0 to 31, and each index will contain where are the set bits. We will check if at particular index 1 is present and we have some count of num2, then we will assign that set bit at that particular index for x. Okay, similarly we will check everything. Now we have two conditions. If the count get finished, or if the number of set bits in num2 are less than required set bits in num1, then we will stop. So that's why we will assign the maximum set bits in the initial of binary string, which is actually the larger number, and which creates the major number, larger number, like power 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5. So we will assign with 2 raised to the power 5, 6 as maximum as possible. If we have count more than the required number, then after the requirement get fulfilled, the remaining we will assign from the back, that is minimum, because we have to provide x with the minimum value. X XOR num1 should be minimal. So let's apply this what I have explained, and we will look how much the time complexity and how the logic works. Okay, so first of all, as I said, we will check the number of set bits in b. Okay, so while b greater than 0 and if b mod to not equals to 0, then count plus plus, otherwise b2. Okay, now we got the count. Now we will declare a vector int c of 32, 0. Okay, and here also while now we will get the set bit positions in integer a or num1. A is greater than 0 and we will require an is greater than 0, if a mod to not equals to 0, then ci equals to 1. Okay, otherwise I minus minus and a divided by 2. Now we get where are the set bits located in A. Now we will assign our set bits as much as possible inside C again. How we will do this? For int I equals to 0, I less than 32i plus plus, and if our count is greater than 0 and ci equals to 1, then count minus minus, because we will basically assign 1 there and that is already present, so same thing. As if count less than equals to 0, then and ci equals to 1, then what we will do is ci equals to 0. Why? Because we are actually creating x now. So by doing this, what we are doing is we are creating x and we don't have remaining ones, set number of set bits, so they will be 0. Okay, now if let's say count is greater than 0 still, then we will go from equals to 31 to I greater than equals to 0 and I minus minus, and if count is greater than 0 and ci equals to 0, then we will assign that ci equals to 1. Else if count less than equals to 0, then just break. Now we will create our number. For int I equals to 0, I less than 32i plus plus if ci equals to 1, then x equals to x plus power of 2 comma 31 minus I, return x. Let's check out ci. How it can be possible? I have done something wrong somewhere. If count I equals to 31, I get an I minus minus. If count 0 and ci equals to 1, ci equals to 0, then assign 1 and count minus minus. Yes. That's the issue. Okay, we got 100%. So today what I learned today, I've given an interview in company named Deserve, that is a startup, and it provide a very good compensation too. About, I'll not disclose the exact figures, but it's in the range of like 17 to 20 LPA. And if you guys wants to know my experience in the interview experience, then definitely I'll create another video on that if you guys want. And this startup actually have very less interview details on the internet even. So the startup name is Deserve, and if you guys want it, then please upvote it, comment out, and I'll definitely share with you guys. So what I learned from today interview is we should know every single line time complexity. So I'll take with me that from today every single line of code that I'll write, I will know in depth time complexity of that, because it will be helpful for me even in future and everything. So for this time complexity big of 1, for this bunch of code, this block, it will be time complexity uh, maximum log base 2 n, log n basically. Then for this declaration, its time complexity is big of 1, int big of 1, then it is big of 1, then again log n, then this is big of 1, because every time for any n figures, n number, it doesn't matter, it always in 32. Here it is big of 1, big of 1, then this will be big of 1, big of 1, big of 1, big of 1. So overall max time complexity is big of log n. Okay, then let's check out time complexity of vector declaration time complexity big of 1. But if we are initializing 2D vector v, then rows and columns, space and time complexity will be big of n into m. Oh my god, that is a new thing that I learned today. But no issues. So see you guys, take care, bye bye.